Welcome everyone in Let's Talk AI. In today's episode, we're with Abiola Trésor Djigui. And Trésor, how would you describe yourself in a few words?
First of all, thank you, Thomas, for having me here and letting me share my experience with all your audience. I'm really pleased to be here. I'm Abiola Trésor Djigui. I'm a Beninese. I come from the Republic of Benin, and I've been residing in France for like 8 years now. And I'm currently working as an AI research engineer at Decatemos. Decatemos is this small startup specialized in strategy consulting. And our specificity is that we mix both human intelligence and artificial intelligence to predict the future, to model the future. And this way, we are empowering leaders to take decisions and build future proof action plans in these times of uncertainties. On the top of my daily job at the customers, I would describe myself as a social pacifier. It is something I like to do. Anywhere there is trouble, I like to get in and I try to bring peace in the environment. This is how I would describe myself from a social point of view. And professionally, I think I'm more than just an AI research engineer. Before all, I'm a data scientist and a data scientist with a specialization in natural language processing. In my ongoing journey in data science, at the early stage, I tried to specialize myself in NLP. Just I want to precise that I have tested like the general data science because for me, data science can be divided into two parts. You have the learning part and you have the modeling part. So learning part is everything related to general data science, and the modeling part is something that other branch made up of natural language processing and computer vision, namely. So I tried both, and I got that systematic bound with natural language processing because it showed for me to be like a mix between science and literature. Since I'm also really interested in literature, I got that bound with NLP, and since then I've tried to do the most projects I can do in the field, and that's how I've been building my brand in NLP, if I can call it that way. So, in a nutshell, I'm a data scientist with a specialization in natural language processing.
Great, thanks.
Yeah.
Thanks for this introduction. I was looking forward to this episode as I wanted to hear more about your expertise in NLP.
Yes.
How do you mix it with MLOps? And also your vision on how NLP have been growing. I really like how it's not the first time that I hear someone say talking about NLP and how we can relate it to literature or psychology, and there are many things, great things to do with it. So, uh, could you maybe share um, the evolution of NLP, kind of from your perspective, and maybe some projects you've been working on through times?
Yeah, definitely. Thanks for the question. It's a quite interesting question because indeed, when you do your first steps in NLP, this is one of the first questions that just pop out because you just face models that look very advanced, and you ask yourself if it has always been this way, or if there was some primary stages that have evolved to give what you we are using today as models. So I think that to make it quick, there are three main steps in the evolution of NLP. You have the birth, which is around 1950s. So it's the birth of NLP, where all the models were like heuristics based. So heuristics is, I would say, this kind of method that we usually use in data science, but that is mainly based on common sense, on rules, on I don't know. It's not rational. It's not perfect, but the advantage is that it helps to reach quick, short-term solutions to the stated problems. So NLP at the beginning was this type of methodologies. So an example would be if we are trying to perform a task of sentiment detection, for example, sentiment analysis. So rule-based approaches would be, okay, if we get the word bad or the word unhappy or the word disgusting in a sentence, then the polarity of the sentence is negativity. But if you get words like pleasant, great, very cool, then the polarity of the sentence is positivity. So this is the kind of approaches that we had at the beginning of the of NLP. But the disadvantage of this kind of approach is that it depends on the domain. It's not domain agnostic at all, because depending on the domain, the way of expressing negativity is not the same at all. So when you want to find the rules, you have to find people that are specialized in the domain, and this is something that is really relating on the expertise of people. It's time consuming because you need to have to find the right people, and then they need to take time to find the right rules. So yeah, that's like one of the limits of the domain. And then when we reached the 1990s, we got the rise of machine learning in general. And what's super cool here is that the experts of NLP at that time, they have managed to leverage all the knowledge of machine learning and apply it to natural language processing. So here we have moved from something that is only heuristics to something that is more general, something that is using machine learning, that is learning patterns and then identifying them in other tasks and giving results. So here, the general pipeline is the same as the one we can get in any other data science problem. So you have your problem, you collect the data. Here, the data will mainly be textual data. Then you process, you do some features engineering to extract interesting features from your data, and then you implement the models. You train them, you test them, and if you say that you think that the models are good enough, then you deploy them. So this is the process that is used here in NLP with machine learning as well. I could take an example to illustrate what I'm saying. Let's take the example of sentiment analysis again. So here, one of the kind of features engineering that we could do is, well, you take the language on in which we are working. Let's say it's English, okay? So you identify all the words in the English vocabulary. Let's say English is made up of 100 words. So you take all the 100 words, and for each word, when you take a given sentence, for each word, you try to find the number of occurrences of that word in your sentence. So you have at the end you have some kind of vector with 100 cells, and in each cell corresponds to a given word, and in each cell you put the level of occurrences of that word in the sentence in the cell, and then you get a vector of 100 sentence, 100 cells, and it's kind of the features of your model. And then you can use any other classical machine learning model we know. It may be trees, decision trees, maybe naive bayes or SVMs. You just put the vectors through the model, and then you get the output. You test, and if you validate, you can deploy. So this is how machine learning had moved from rule-based approaches mainly to NLP. Sorry, had moved from rule-based approaches to machine learning-based approaches, and then around 2010, you've got the rise of deep learnings. So here, this has been something quite revolutionary in machine learning, because the advantage here is that we have tried to build things that are more general, because in the example that I gave before for machine learning, the main limit is that we don't take into account the orders of words when computing the vectors. Like if I take the sentence, for example, the sentence "I am happy" or "Am I happy?" In the first one, I am saying that I'm happy, but in the second one, I'm asking if I'm happy. So I can't really say that the question "Am I happy?" is positive or negative. I'm not expressing any sentiment. I'm just asking a question. And with the machine learning approach, where we just look at the number of words occurring in a sentence, we don't take into account the order of the words within the sentence. So language is a sequential object. Like when you using language, you have to take into account that sequence, because when the word is occurring at the beginning of the sentence, it does not have the same meaning as when it is occurring at the end of the sentence. And here, with deep learning in NLP, this will be that aspect that had been ignored so far that will be taken into account this time. So words are represented as embeddings, and the model that was widely used in NLP is RNNs for recurrent neural networks. So when you're processing a sentence, you go from left to right, and every time you're linking the current words and at which you are spotting to all the previous words you've met in the sentence, and making links, connecting words with each others has just helped to understand more the global sense of sentences and not just taking words separately. And then in the ecosystem of deep learnings in NLP, we've moved from RNNs to transformers today. And one of the most famous models using transformer is BERT for a bidirectional encoder representation from transformers. It's like it was one of the revolution of deep learning in NLP. It was, I think, around 2017 approximately. And today we are at the autoencoders level. So to make it short, you have rule-based approaches at the early stage of NLP. And then at the middle age, you have machine learning, which is also applied in general data sciences, data science with quite classical approaches. And then today you have deep learning with RNNs at the early stage of deep learning ecosystem. And nowadays, transformers, which are something that are really specific to NLP because transformers have been invented in NLP. Well, today they apply to other fields such as computer visions, but it is the product of NLP.
Thanks for
Yeah.
doing this overall story. I would like to go in depth of every one of them, but the question that I have on top of my mind right now is: so what changed between RNN and transformer models, and how transformers are better, and like what do transformers do that are better than what we were doing at the beginning of deep learning?
Okay. That's a good question as well. RNN, the way RNN work is that they go from left to right. Okay. So if I take the sentence "I am happy," for example, I take the word I take its embedding. Like the embedding is you just take the word and you represent it in a vectorial space. So you represent you replace your word by a vector. Okay, then you take
Hmm.
that vector and you kind of extract some hidden state from it. You take that hidden state that is an information that is coming from the word I. You combine it with the embedding of the word am, and then you combine the two. You extract a hidden state. You take that hidden state. You combine it with the embedding of the word happy, and you combine the two, you extract a hidden state, and once you hit the end of the sentence, you take that final hidden state that you have extracted to do your inference to get the result depending on the task that you are trying to solve. So it's some kind of approach that is unidirectional. You go from left to the right. So when I am at the word am, I have not seen the word that is coming after the word am, which is happy here. So I don't have any information from the word coming on my right. But with transformers, it's bidirectional. Okay. So when I'm at the word I'm taking the information from the previous words, but I'm also taking the information from the words that are after my words in the sequence. So how does this technically works? So you take your sentence, you have all the different words. Actually, in the NLP ecosystem, we don't use the word, but we use tokens. So you don't split your sentence into words, but you split them into tokens. And when you get the tokens, you embed each of the tokens, okay? And then you do something that is called positional encoding. So it is an information that is giving the position of each word in the sentence. So to each embedding, you will add an information that depends on its position in the sentence. The idea here is that when I have a word, if it is at position 2 in a sentence, in another sentence, if the same word is at another position, it shouldn't have the same impact on the final result. So you add something to save the information of the position to the embeddings, and then you do this kind of where of similarity. So you just take each word and you represent it as a combination of all the other words. Okay, so you take, let's say you take the word am in my sentence, I am happy. So you will say that the verb am is a combination, is a linear combination of the word I and the word happy. And this way, you are just taking the information of the web from the word happy, but also from the word I, and that's where the expression of bidirectional encoding comes from. So you encode from the right, but you also encode from the left. And in NLP, the most information you get, actually, the better will be your results. So this is the difference between RNNs and transformers. And the other difference is also in terms of complexity, because with RNNs, it's like the the training step is very long, because you iterate one word after the other in the backwards process. When you're trying to optimize your loss function, you iterate one word after the other. But in transformers, everything is represented in terms of matrices. So you just take all the words, all the embeddings, and you just compute scalar products to do the linear combination of words to get the others, and everything is just matrices multiplications, and it just goes way faster. So the difference is in terms of the way of encoding. So RNN is unidirectional, transformers are bidirectional, and it is also in terms of complexity, as RNNs is iterations one words after the other, and transformers are only matrices multiplication.
Great, thanks. Thanks
Yeah.
for this clear explication of both of those models. Um, and so, um, so are you more used to train transformers on a daily basis? Do you use more transformer, or it really depends on the project you're working on?
I would say it's not that systematic to choose which kind of approach you want to use. Sincerely speaking, RNNs are kind of dead now. Like, no one is using them anymore, because they are like just less precise than transformers. They are less accurate, and in terms of time, they are way more consuming than transformers. So, because they are supposed to provide that deep understanding of synthesis, and this
Hmm.
advantage transformers have it too. Okay, and at the
Hmm.
same time, they RNNs have this disadvantage of being really low at the training step, and transformers are like more they are quicker when you are trying to train them. But the other truth is that we don't really train transformers, because they are made of billions of parameters, and not all people have the hardware power necessary to train them. So we would be in some kind of fine tuning more than training. Like, you get the model, there are some steps, there are some layers that you don't touch, you freeze them, and the top layers may be a linear layer on the top of all the networks that are at the beginning of the model. You freeze all these, and you just train the linear layer on the top of the model. So I won't use the term training, it's more fine tuning. And when it comes to choosing between RNNs and transformers, people will usually prefer using transformers. But depending on the project, you may want to go to approaches that are less deep learning oriented. I mean, sometimes you don't have no reason to choose transformers, because these models are just too much powerful for the task you are trying to solve. And I believe that what is the most important is to find a solution to a problem, and not choose a model that is too much complex. There is no use in this. You first try the simple models, and it's only when they don't work that you move to more complex models like transformers or auto encoders.
Thanks for this
Yeah.
answer. It makes a lot of sense. Um, Something very related to these points that you just made, whereas you're going to use decision trees, like more machine learning models, or you're going to use more advanced model with transformers, depending on the tasks you need to achieve. Maybe you could share with us about the challenges that you face when you're going from this theory to the real world. Maybe you can share some projects you've been working on, or some use cases you've been having, some things that you needed to figure out, and which model did you use in that case. Could you have some examples of that?
Yeah, sure. Yeah, sure. Because I've been doing quite a lot of applied R&D projects. So definitely, just to introduce, there is a gap between theoretical NLP and NLP applied to real world use cases. And I think that this gap first occurs when it comes to the aspects of the data, because generally when you read research papers in NLP, you will see that the kind of data that they use is generally clean, okay, and it is like specific to a given domain. NLP research papers are rarely domain agnostic. And
Mm-hmm.
this difference between the data that is generally presented in a research paper and the data that you get in real world use cases may
Mm-hmm.
occur in terms of the style. Like, let's say you have a paper um, ex- doing experiments on a given model, okay, for sentiment analysis, for example, and the text that they used came from newspapers articles, okay, and the text that you have for your use case uh, come from Twitter. The style of expression is not the same at all. In newspapers, it's more sophisticated, and on Twitters, it's more popular. So the style is not the same. And what we often notice when practicing is that this aspect of style of language has a big influence on the final results. So filling that gap is something that is quite challenging. Shifting your language from a style to another one, or a level of complexity to another one, is something that is quite challenging. And once you filled that gap, for sure, you can now apply your model. But indeed, sometimes you expect that a model that is complex will work, but finally you end up with something that is more simple than what you was expecting. One experience that I can share is that project I worked on. That was about establishing links between companies and coal power station. So it's something that was related to climate change and a green environment. So to introduce the project, it was okay. We had a list of companies, okay, and we also had
Mm-hmm.
a list of coal power plants. And what we wanted to identify is if in my list of company there is a company that was linked to one of the coal power plants that I had, and the link may be a link of sponsorship, for example. If a company is sponsoring a coal fire station, if a company is financing these power stations, if a company has merged with this power station, if it's the parent of this power station. So the problem was stated this way: there was no idea at the beginning of using NLP or anything of that sort. So the way we proceed is, okay, if generally, like, if a company is merging with another one, or is becoming the sponsor of another company, this is the kind of event that is covered by the press. So what we said is that if this kind of information exists somewhere, we may probably be able to find it in newspapers articles. So newspaper articles, good sources to explore. Okay, then if a company is a parent of another company, here a coal power station, this is something that may be found in the Wikipedia page of the company, for example. Like when you go on the Wikipedia page of a company, it is said in the introduction, for example, that it's a child company of this other company. So Wikipedia, newspaper, good sources to explore to achieve our goal. Okay, so
Mm.
here we have two different sources, and the common basis between these two sources is that they are made of text data. Okay, text data, NLP, quick link was made here. So now we had text, and what we were wishing is being able to extract the information of relation between two entities. So you have text, you have a coal power plant name, you have a company name, and you want to identify if there is a connection between those two entities. First, you take the text. The first step is to identify if the text is about the company you're looking for or the coal power plant you're looking for. And this is a quite common task in NLP that is called NER for name entity recognition. So you apply name entity recognition. I mean, okay, for name entity recognition, you don't have that much choice. You don't have to choose between rule-based approaches. This is something, yeah, it's like you just use the deep learning models that exist and you perform your named entity recognition task. So once you identify the two entities, the big challenge was about the way you model the link between the two entities. Or if you have a paragraph speaking of a power plant and a company, how do you say that, okay, this company is sponsoring this one? Will I just look for words like sponsor? Like if I find the word sponsor in the paragraph, I will say that there is a sponsorship link between the between the two entities. Will I just look for words like expressions like child company or parent company? If I decide to go with this approach, I would be taking something that is more close to rule-based approaches, like tagging specific expressions. And for that, I will have to reach out. I will have to find experts in terms of companies sponsoring each other or merging together, so that they can provide me with expressions that characterize that kind of relationship. Okay, this is a way that could have worked, but you have then to find the experts, you have to find the people that will help you establish all the links. So this way we decided to not go with it, because we just don't had any way to find the experts. So we needed to find to set all the expressions. So the other way of doing this is you can use a model, okay, where you have three entries. The first input is the name of the power plant, okay. The second input is the name of the company, and the third input is the text, the paragraph that contains both the power plant and the company. And at the output, we modeled it as a classification task. So you have like three links, for example, sponsorship link, okay, merge a category, like the two companies are merging, or the third one is I don't know, partnership, they are partnering, okay. Then you take first input, that is the name of the power plant, second input company, third input paragraph, and at the output all these three entities will be classified as merging, or as a sponsorship, or as partnership. And so this is how we decided to model the problem. So here to reach this, we decided to use transformers, because what is super cool with transformers is that they have that deep understanding of the way language is built, all the complexity behind languages, all the synonyms, because when you're using role-based approaches, you have to cover everything. But here, these models have the possibility, the capability to generalize by themselves. Okay, so we just give them the sentences. They learn to I mean find the patterns when a paragraph is about partnership or sponsorship, and then classify everything in the right manner. So this is the approach we decided to go with, and this is what we judged to be the most convenient regarding our problem, because we had this difficulty to find experts to help us set rule-based approaches, and we had, I mean, the possibility to use transformers and everything else that is quite generalizable. So yeah, we decided to go with that, and we were quite happy because we got a precision around 86%, if I remember. It was like 1 or 2 years ago, and in NLP, this is a very good score, actually, to be honest. Yeah.
Awesome, awesome. Yes, this gives a great overall picture of how you're using NLP, a real case, how you implement transformers, what do you decide to use as inputs. Um, I feel like that's very insightful. I was having, so you said you decided to use precision as a metrics. Do you use other metrics to evaluate your model?
Um, on the use case that I just described, we used precision indeed. But in NLP in general, you don't necessarily use precision. I mean, it depends on what you're trying to do.
Mm-hmm.
Uh, I could take the example of translation, for example. This is
Mm-hmm.
a quite common use case in NLP. When you're doing translation, you don't use precision. It's like more of the word error rates, that kind of thing. Like you take your input sentence, you translate it into the targeted language, and you try to find which words have not been translated, for example, or which words were translated but were put in the wrong order. So you have the blue score or the word error rate score. So it really depends on the task that you are trying to solve. Here, on
Mm-hmm.
what I just described, it is more a task of sentence classification, that kind of stuff. So it's more classification metrics like precision of
Mm-hmm.
F1 score or recall or other scores. But we used precision to
Mm-hmm.
evaluate the performance of our model. There
Mm-hmm.
are also some other tasks in NLP that don't have like proper way of being assessed, such as topic modeling today. When you have a corpus, we try to infer the different topics that the corpus is talking about. When you identify them, there is no proper way today to measure how accurate is your inference is in terms of topics that have been detected. So yeah, I
Mm-hmm.
would say that in NLP in general, there is no fixed set of metrics to be used. It all depends on how you model the problem. If it is a problem of classification, then you use the metrics of classical classification in general data science.
Great. And
Yeah,
you were mentioning in your model that you had three outputs. Three inputs.
three
So you
inputs.
had
Yeah,
the power. How did you say it? The power call, the power center,
the power station name.
the power station. The second
Yeah,
one, I'm not sure what it was.
the company name, the company
The
that you are
company name,
trying
right?
to link to the power station.
Yes, and the link, so the link to the article, this input can be, so the ID when you're, because I assume that then you want to automate this to like picture, like to understand the big picture, right?
Yeah, yeah.
Like, do you decide previously to have all the links to the articles, or do you do something that try to look around a lot of links and try to pass those links into your model, and if like it matches specific conditions, whereas under like finding the name of the company or the name of the power center, then
Yeah.
you decide to use this and apply the model, like how was the overall thing working?
Okay, so if I understand well, your question is more about how did we decide the links into which we were trying to classify the triplets of input?
Yes, yes, yes. That's my
Was
question.
that okay? So well, this is a good question because this is where I may be able to talk about business importance, because when we tried to model our problem this way, this was a question that we were asking to ourselves, like how do we define the set of links into which we wanted to classify. Okay, and this is where we went back to the client and asked him. We just told him that the way we were going to model the problem, we need to have a predefined set of relationships. We can't just go into the wide and hope to cover all the kind of links that may exist out there. So we need you to help us define a set of links that you want us to target. And together we defined like 5 links. If I remember well, you had sponsorship, you have partnership, you have parent, you have child, and I think you have financing or merging, something like that. So we defined this set of 5 links. We then had some data that we annotated ourselves. Like we had text, we had the different companies within the text and the kind of link they were sharing in that text, if it was a link of partnership. So we had this kind of whole data set where you have first you have company, you have coal power plant, you have text, you have link. Okay, and
Mm-hmm.
so it just comes to a problem of classical classification. Okay, classical
Mm-hmm.
classification where you have a set of classes of categories into which you want to classify. And just maybe something I didn't say is that may not be clear is the way you use the triplets of inputs here. Just
Mm-hmm.
yeah, don't forget that in NLP the output at like the early stage of the pipeline is always text data. Here we have
Mm-hmm.
like 3 text data. What does that mean? I mean, how do we use them? Well, generally in NLP, when you have multiple inputs, you concatenate them into one input. So you take first input, on the top of the first input you add the second input, and on the top of the second input you add the third input. But here you have to specify to your model a way to distinguish each of the inputs. So generally you
Mm-hmm.
add a homemade token. So you add like a homemade word every time you are sticking 2 inputs together. This is what we generally call the SEP token. So it's I don't know. For example, you take your first token, you add SEP. You take the second, your first sentence. Sorry, you add SEP. The second sentence, you add SEP, and then you add the third sentence, and you give this whole sentence to your model. And during the learning process, the model will just learn that before the first step, there is some information that is useful. After the first step, same. Before the second step, same. And after the second step, same. This is like something you expect your model to learn. So at the end, even if we have 3 inputs, what we present to the model is one textual object where all the 3 inputs
Mm-hmm.
are concatenated together to get one sentence or one paragraph.
Mm.
Yeah.
Okay. I have one last question regarding this example. I feel like we're
Yeah,
taking
sure.
time, but I feel like it's very passionating hearing you talk about NLP and a specific use case because it really gives perspective. Even though we're just only talking about a classification problem, and this is not very representative of what can be done in
Yeah.
NLP, but like for example regarding this third input, which is the text. I understand
Yeah.
it's all the text from the page. So do you have like a pre uh, pre processing of the text of the page before inserting it into the model? Do you like separate each sentences in strings, or do you, like how do you process this raw text to put it on your third input of your model, which you've separated with some step in the feature engineering process, if it's that's correct.
Yeah, yeah. Well, I get your question. Um, okay, text preprocessing in NLP is something that occurs quite often. Well, in the use case I described, we didn't do any text preprocessing because we were in a domain that is relatively clean. I mean, when you scrap text from Wikipedia, it's a well-written text. You don't have to remove some noises. When you scrap text from newspapers, it's some clean text. You don't have to remove noises. So we didn't have to perform any text preprocessing step here before going into our model. But in general, in NLP, in real world use cases, some preprocessing is just needed because, well, even in our cases, the newspapers that we used, we scrapped them ourselves. Okay, and sometimes when you scrap a URL, what you get is not really text, just like some ads information, and you have to detect the kind of text that are not text, and you just like filter all the link out, but the links that you keep, you don't do any preprocessing after that in our case. But in general, you may have texts that are not English, for example, and the model that you are using is very adapted to English language. Then you have to do what is called language detection, for example, to detect every article that is not written in English and only in French or in German, and filter it out. So yeah, you have this kind of preprocessing, and the other kind of preprocessing you may have is a kind of preprocessing that depends on the model that you are using. For example, we used BERT, if I remember well, and BERT has a limitation in terms of the length of text it is taking. So when you split your text into tokens, you cannot have more than 512 tokens. When you exceed that number, that you will just have a memory leakage, and the model will just bug. So you have to split your text, for example, into small pieces. So you may split them into paragraphs, because you assume that paragraphs are not longer than 512 tokens. So yeah, you have this kind of preprocessing, and you just have to adapt depending on the situation and depending on the kind of models that you want to use.
Mm,
Yeah.
mm. Yes, makes sense. Okay, thanks a lot. Um, I think I will ask the last question regarding this specific example, but it can go to a generic question. So now you have trained this model. Um, uh, how do you go in production with an NLP model? Like, did this model that we're talking about went into production for the clients? And yes.
No, go ahead. Let me let you finish.
So, so did this model went into production? If yes, can you tell us more? And if no, can you talk a bit more about how NLP models can go in productions and maybe introduce MLOps?
Okay, okay. Yeah, the model went in production, but not by us, because what we implemented was just an MVP. So it's just a demonstration that there is a way to do something to solve the challenge, and then we handed the project to another team that took the lead and put the model in production. So yeah, it went in production. But you just mentioned MLOps, and I believe it's something important we should definitely talk about, because when you implement a model in your notebook and it does not go to production, for me there is no use in implementing models if the final idea is not to put them into production. So MLOps, I think one of the most popular practices that we can make a parallel with is DevOps. Okay, like
Mm,
DevOps
mm,
today is just some kind of way to put some fluidity between the interactions between the developers and the operations professionals. So the mind behind DevOps today is provide the ability to code quickly, to test quickly, to deploy quickly, and also to maintain. Okay, so MLOps on its hand is a little bit more complex, because on the top of coding, deploying, and maintaining, you have all the tasks of designing the way you want to model. Okay, data collection, data engineering, and after data engineering, you may have some feature engineering steps. Although this is not anymore necessary with deep learning approaches. But after that, you now have the code for the model, the code to train the model, the code to test the model, the code to deploy, and the code to maintain. So MLOps is covering all this pipeline. It's from the beginning until the end. And the importance of MLOps is that it allows some kind of quick interactions, and it just provide more times to data scientists to focus on what they do the best, which is models implementation. Because what we can notice in most companies today is that the step of training and testing is done like manually by data scientists, and this kind of stuff should be like automated in companies, and data scientists should put all the efforts on implementing. Like today in my company, we had this issue of like when we have a model that depends on parameters, and we want to I don't know, you develop the model, you put it for access by the consultants, and they want to twist parameters, like to play with different parameters to see how the model works. They have to reach out like to the data science team, so that a data scientist can play with the parameters and see the impacts on the outputs. And this kind of stuff we are trying to automate it today, so that a business consultant on his side can directly take a model, like change the parameters and see the different impacts that this is having on the final results. That way, the data scientist won't be bothered anymore with can you try this parameter for me? Can you play with these parameters for me? And MLOps is about allowing this. It is about allowing business consultants to interact with the pipeline without involving data scientists, so that they can be fully focused on the step of implementation. But on the top of allowing interactions between data scientists and operations professionals, it is also allowing the collaborations inside the data science team, because you have these kinds of tools today that are how do you say it, that just allow you to quickly develop models. So you have many tools that put how do you say it, endpoints to models that are
Mhm.
pre-trained, that you can quickly use, quickly call in your stack, and develop a pipeline that is actually quite robust, and it just helps to gain a lot of time. So this is all what MLOps is about.
Mm.
Yeah.
Mhm. Thanks a lot. That's very. I really want to to do more episodes on MLOps on the podcast. I will
Okay.
maybe in the future ask you to come back again. We'll talk only about MLOps because I
Sure.
feel like this is really a key thing and like knowing. So maybe I would really like to ask you because of the time of the episode is running. I have two main things that I want to ask you.
Yeah.
I would like to hear you one entire more hour learning about what tool do you use, how do you face a new project, how do you approach tasks that needs to be done, how do you evaluate all the models, how do you build an MVP. I have all these good questions, but maybe for another time.
Yeah.
Maybe before switching to your vision of the future of NLP, what are the tools that you use on a daily basis today?
Okay, okay. I think nowadays we are quite fortunate, because there are a lot of open source tools out there that just allow to, do quick experiments, quick like exploitation when we have a specific use case. We have tons of open source tools out there. So personally, I mean, many of people in your audience will probably know about Hugging Face, which is this platform providing a lot of endpoints to models that are quite specific to NLP today and are really transformers oriented. So it's only state of the art as far as NLP is concerned. So I use Hugging Face a lot, and when I say open source, it's really open source, because they provide you with the link to the source code, so you can even play with the models. You can
Mhm.
change some parameters, like mask some layers, add some layers if you wish. They also often provide some kind of code template so that you can just jump to quick experiment and quick running to see the outputs by yourself. But in top of that, you also have many other links, like many other open source research platform, research libraries like Allen NLP. I believe this is like one of the best, okay, the best platform of endpoints to NLP tasks such as named entity recognition, reference resolution, post tagging, and so on. But I believe it's important to be able to
I'm sorry,
find
Trésor.
libraries
I'm not sure I can hear you anymore.
on Google as well, because on GitHub you have many libraries that are around NLP tasks, if it's about topic modeling or sentence classification or textual entailment. You have many people that are using GitHub that are implementing on the top of tools such as NLP and NLP or Hugging Face. So all these tools are out there, and even in NLP, I would say let Google be your best friend.
Mm.
Also, maybe I won't forget Spacey and NLTK that are quite important tools for everything related to text preprocessing. You have powerful tools there when it comes to lemmatization, I don't know, name entity recognition, stop words removal, and all those kind of stuff.
Great. So we're running a little bit out of time, but I want to thank you for all those questions, and I have three short questions. So the first one is, how do you improve yourself in your career and on a daily basis?
I would say reading a lot. Like I believe my career will mostly be about being on that bridge between theory and practice. So yeah, it's important for me to be reading a lot of research papers, a lot of research articles. I think it's a powerful way to understand how people think, how people try to solve issues, how people try to approach problems. So that's the principal way I would say to like maintain my way of solving NLP related problems by taking inspirations from researchers. And the other way is, I mean, work in the good team. I've been fortunate enough to work with people that are sincerely quite brilliant. I've been learning a lot from them. I'm still learning a lot from them. And I think it's important to find the right people in the right domain to work with. That's super important. Yeah.
Okay, thanks. Is there a way people can connect you, reach out, or maybe see your work, your publications? Do you have anything uh, to say
Um,
if people want to know more about you?
yeah. I think everything is gathered on my LinkedIn. I've tried to put everything about myself there and everything about my past realizations there. And the coming ones will also be posted there. It's always cool to, I mean, to talk with people, to say what we know and learn from what they know. So definitely, people wanting to reach out can reach out on LinkedIn. I'll be more than happy to exchange and answer.
Awesome. And last question, do you have a message
Yeah,
that you want to share, maybe regarding NLP, a personal message? Do you have something to share with us?
writing NLP, I would say NLP is the future because we are in an era where everything is on social media, where everyone is talking, like everyone has the right to speech, which is a good thing. I'm not criticizing, but like the downside of this is that everyone can say whatever they want. Everyone can bully anyone. So it's important to regulate all this, and the only way to regulate all this is to be able to treat what people are saying, how people are expressing themselves, and what should be banished, what should be monitored, and this kind of stuff. So we are at this era of protection of people, of filtering of what they're saying, and this the only technology that is going to help us reach this goal is NLP. So I believe NLP is the future. in terms of AI, in terms of automation, in terms of I don't know, tech scalability. I believe NLP has an important role to play in this future. So I encourage everyone interested in NLP to just go for it, because there is a lot of challenges in the field, as in the research field as well as in the practical aspects. So yeah, go for NLP. That will be my last word.
Awesome. Thanks a lot, Trezor, for the episode. I'm
You're
very
welcome,
happy
Thomas.
we were able to record together, and I wish you all the best regarding your projects coming and life in general.
Thank you, Thomas. I wish you all the same, and have a nice end of weekend in Madrid.